good morning, good evening, good afternoon, wherever you are. My my name is Vishnu Dutt, and in this session, we are going to learn about transmission control protocols. So, to introduce myself, I work in Cisco for enterprise customers, and I have an expertise in network security, data center, and route and switch. Right. So, in this session, we are going to talk about mainly transmission control protocol. Uh, and if we know, so let's discuss first the agenda, what exactly the agenda is for today's session, right? You all know that we all are here to understand TCP, right? And TCP is a pain point for most of us. And if I if I tell that uh, we can cover the TCP in just 1 hour or 3 hour, it is not going to be the case. Absolutely, it is not going to be the case because to learn TCP, you need to spend some time, right? And today's session is going to be only 3 hours long. And I'm pretty sure that we are not going to cover everything of TCP in 3 hours. And that is why I am creating a full course, right? So this course is between 9 to 12 hours. So you can understand that there are going to be 2 or 3 sessions more, right? And we are going to have them on Sunday, means if you can spend time. So, but I promise you one thing, if you spend those 12 hours with me, then with respect to TCP, there is not going to be any problem. Whether you are preparing for an interview, whether you are troubleshooting any network problem, or you are talking about TCP in any podium, you are explaining TCP in any podium to any customer, you are going to be pretty good with that. And why I'm saying this? The reason is we are going to learn from real life examples, right? We are going to introduce some of our characters like Anjali and Rahul. If you have seen my videos, those are going to be with this course for 9 to 12 hours. We are learning from real life examples, and the most important thing is I am going to show you everything on WireShark. If you do not know WireShark, that is perfectly fine. But what I wanted to say is we are going to see everything, every packets live. Okay. So be with me. It is going to be pretty interesting sessions. So welcome once again. Thanks for giving me your Sunday 3 hours. And let's talk about the agenda, right? So first thing first, we are going to start with why exactly TCP, right? There are some motivation to create this session, to create some of the videos, and there are some technical reasons also that why TCP, right? And believe me, if you understand why behind things, you know or you can understand the concept well, right? And that is why basically I decided to have my company name as BridgeWire, because we bridge wire. Okay. And you can see how we simplify the thing. So first thing first, we are going into the reason why exactly we are learning TCP, or why behind this technology also. We are going to see this from 2 real life examples. Okay. And then uh, uh, my strategy is, if we are working on a complex solution, for example, TCP for many is a complex problem, and it is, right? If your approach is not clear in learning this TCP, it is going to be pretty complex. But believe me, if we break that problem into multiple pieces and then learn that piece, then it is going to be very, very easy, right? We are again choosing the same thing, that we are going to break TCP into multiple parts and then learn the individual part. And then at the end of the session, we are going to combine everything to make one solution. Okay. Then there is a lot to learn from how do we communicate. And I am taking an example of 2 people talking over phone call. And believe me, all TCP is implemented from real life examples. If you understand those real life examples, what are the things which we need to consider when we talk over the phone, right? It is really, really important. We can learn a lot. So I am going to take this example and then compare it with how 2 computers talk. Believe me, it is going to be important to understand the terminology in TCP, and then we are going to introduce some terms because terms are really important, right? If I'm saying flow control, then flow control is known by everything who knows TCP, right? If you give the terms your own name, nobody is going to understand but you, right? So we will be introducing some terms. So starting 30, 40, 50 minutes, there is not going to be any term, just the building of how we are going to learn TCP and what exactly we are learning, and in simple manner. Okay. Then there is a problem of missing packet. If you have seen my video on YouTube, there is one packet missing, which is creating a lot of issues between Anjali and Rahul. Who these characters are, we are going to discuss. Do not worry, right? Then a lot of people say that connection establishment is required. Yes, it is required, but how it happens, right? Why exactly it is so important to have a connection first in TCP? We are going to understand this. Then we are going into the concept of sequence number, concept of acknowledgement, and then most misconception part, right? The problem is whenever you try to learn TCP, you start from anywhere, right? From you see a topic that interview guy has asked MSS, you go and start learning MSS. It is not, shouldn't be the case, right? If you are learning anything, you should start from the scratch. Okay, so this is the problem, that people do not understand that there are two streams. One is from client to server, and the other one is from the server to client. Although I can see some hand raises right now, right? But let me complete starting 1.5 hour, and then I'm going to uh, allow you for asking question. But give me some time so that I can complete whatever I wanted to tell you in this lesson. So uh, hold your horses for now, right? And I will be coming back to you with your questions. Do not worry. Do not worry at all, right? So as you can see that after that there is a favorite topic of everyone, which is TCP handshake, and then we are going to see everything in action. Everything in action means we are going to see packets. We are going to go inside those TCP packet, TCP segments, and we are going to see what exactly is there in those TCP packets. Okay. And if time permits, we are going to cover some part of the flow control. But if it is not, then basically you are again welcome into the second session. But believe me, if you give me 3 hours for today's session, you do not want to miss the remaining part of this course, right? So having said that, let's start. Let's work towards our first board, which is why TCP, right? And here is why TCP you want to learn, right? Actually, this course is for everybody. And the reason is, suppose you are a student, right? You are learning networking. This course is important for you because TCP is important as a part of your curriculum. If you are a network engineer, which is having 2 to 3 years of experience, this course is for you because believe me, TCP understanding is must, right? And I'll let you know why exactly it is must. If you are having experience from 15 to 20 years and you know TCP well, that is perfectly fine. This course is going to brush up some of your concept. So this course is for everybody, 2 to 3 years, 10 years, student, designer, everybody, right? And why I'm saying this? Because you all know that we have TCP IP model, and in TCP IP model, we have these 5 layers, right? And as a network engineer, uh, we are very good, right? We are good with respect to data link layer. We are good with respect to network layer. If anybody asks us BGP, if anybody asks us OSPF, we are so much sure about it, right? No problems at all. If there is an application engineer or server guy who is pretty good with respect to this application, no problems at all, right? Now, what is the problem in this model? So I'll take an example from my work that most of the times we see problems from our customers, that their users, right, who is sitting in a particular branch, say this is their branch 1, right? And somewhere they have this data center in which they are running some server, and on the server they are running some application, say, right? And this guy is happily accessing that application, but after some time he says that the application is not working, right? So there is an immediate call to you if you are a network engineer and you are going to check whatever the routers and switches in between, and you say, okay, the route was missing. I have found the problem. You are capable enough because you know BGP, OSPF, and routing so much, right? You are going to get make sure that that route is installed. Now again, this user is saying, right, and it happened in my environment in several times. This user is saying, although now it can able to access the application, but the experience is not good. If I say experience, means the application is pretty slow, right? Then you say to this user, do not come to me. I'm responsible only for making sure the routes are there. But you cannot tell all these things to the user, and user then move toward the any other guy who is the application guy. Application guy says, it is not my problem. I can see my application is performing well. I can see whatever the memory and whatever the hard disk space or CPU, whatever is required, I have given everything. There is no problem at all with respect to application itself or the server itself, right? There is a no problem from network side. There is no problem for application side. Then where exactly the problem is? It doesn't mean that this problem is not going to be resolved. There is somebody who is going to resolve the problem, and that some smart guy has this knowledge. Which knowledge? This guy know TCP also, right? So he asked network guy, can you give me WireShark capture? What exactly going when what exactly is happening when you are making connection to this application, right? And then this guy, because he's smart, he knows TCP, he immediately gives the solution to you, right? And now the question arises, if you are a network engineer, if you are a student or having experience of 15, 20 years, right? Most of the times, because we do not know transport layer well. And one more thing, if I am saying transport layer, I am talking about TCP. Although there is one another protocol which is UDP, which is very simple, we can learn it anytime, no worries. But TCP is slightly bigger concept, so we are capturing it now, right? But if I am saying transport layer, your mind should process this way that I'm talking about TCP, right? So this guy knows transport layer well. It means that this guy knows TCP well, and that is why he was able to solve the problem, because the problem was at the transport layer, right? What I was thinking is that as a network engineer, because we understand a lot of things, right? We have spent hundred of hours in learning BGP OSPF, right? I am saying spend at least 12 to 15 hours in this, and believe me, you are going to be good. Nobody wants to take the responsibility of transport layer because nobody understand it well, right? And believe me, people do not take responsibility because they don't know things. If they know things, they are going to take the responsibility. And my request from you is, let's cover one more layer. What is wrong in that? We know till network layer, it is pretty good, no problems. Let's understand transport also. Let's take the responsibility of transport so that whenever there is such kind of problems, you accept those problems well. You don't say that it is not my problem, right? So one motivation should be, or why you are learning TCP is that nobody wants to take the responsibility of transport layer, right? And believe me, if you do so, if you understand transport along with network and data link layer, it is going to be pretty good with respect to your networking career. और अगर मैं हिंदी में बोलूं तो बेसिकली ट्रांसपोर्ट लेयर चार चांद लगा देगा आपके करियर में. Okay, so this was my first motivation, and now understand that why TCP is required, right? If you want to understand this protocol itself, then TCP is a need, right? And sometime if we need to understand a particular technology or concept, right? We start, let's try to think that what is going to happen, right? If this technology is not there at the first place. So we, for a couple of minutes, right, for a couple of means 5 or 10 minutes, we will forget that there is a TCP or TCP kind of thing, right? And then we can see that what are the problems that can happen if we do not have TCP, right? So we are introducing two characters. If you have seen my videos already on the YouTube, you already know about them. But you, if haven't, then let's talk about them, right? If you see some Hindi movies or basically Bollywood movies, then you must be aware of these two names, Anjali and Rahul. These are pretty common names, right? And these are common names in India too, right? So there are two people here, Anjali and Rahul, right? And Rahul wants to take Anjali on a date, right? So they both agrees and they are on a date and they are talking and everybody is happy, right? Now, Rahul took this opportunity to propose Anjali and said, I love you, right? And Anjali was not expecting it. So basically, she was saying that I need some time to think. And this is the normal thing, right? Because she was not expecting and she was saying that she needs some time. And then Rahul said, it's fair enough. And please do reply me on that whenever you have time to do that. So Anjali said that, okay, I will reply. Yeah, I'll reply on maybe via phone or WhatsApp or any application, right? So Anjali went her home, right? That it is over. And now Anjali decided that, okay, she wants to give the answer, right? So uh, Anjali decided that she is not going to call Rahul, but she is going to use an application, maybe WhatsApp or any other application, right? And she is going to inform, she want to use internet to inform Rahul, right? And by the way, what I have done is from this TCP model, if you can see TCP IP model, generally it is having 5 layers: physical, data link, network, a transport and application. So there is no transport layer here, right? Because we want to understand the importance of TCP, why TCP, right? From the factor that what is going to happen if TCP is not there, right? So let's see. So Anjali typed the message. Unfortunately, Anjali said that I don't love you. Okay. These four, or basically you can say, I will use these two terms interchangeably, right? Segment and packet. But you can argue with me that segment is the layer unit at the transport layer. Packet is the unit at the network layer. That is fine because we are so into the packets that whenever see information, we see packet because we are network engineers, right? So sometimes segment is specific to the transport layer, but sometimes I make mistake in packets and segments. But you understand that if I'm talking about application layer, I'm talking about segments, right? Segment is the unit of data at transport layer and the packet is the unit of data at network layer. So do not worry about it. So basically application, WhatsApp application created this data, which is I do not love you, I don't love you, and pass it to the application layer. Application layer done some formatting, something in that, and then because there is no transport layer and you know that how traffic flows onto a particular stack, it is going to be delivered to network layer, right? And one common question for the students or who the guys who are just starting their networking career, believe me, most of the guys do not even know where exactly these layers are, right? They do not know where these layers are implemented. So I would like to mention one thing here. Any device, any device who is capable of talking over internet, whether it's your mobile phone, whether it's your laptop or iPad, anything which is capable of talking over internet or can use IP, TCP IP, all the layers are implemented right there, right? So inside your phone, there is a full TCP IP layer, or we call it TCP IP stack implemented, right? If I say TCP IP stack, the meaning is just simple. All the layers are implemented, but what I have done here is I have removed one layer out of it. So while layering approach, this is a whole solid different concept. We can discuss about it, but if I go into that, then most of our time will go into that. So we are not talking about this layering approach. Just have a look at my YouTube videos. You will find something over there, right? But right now, I have just removed this transport layer from TCP IP stack, right? So it means that whatever the application is providing to me via application layer, right, it is coming directly to network layer, and network layer is saying that, okay, I will put a packet, I will make a packet I, then don't, then love. I have these 4 packets with me, right? And now network layer, network layer, what it is going to do is that this is the data which is I am having the first packet, which is I. It is going to put source and IP information. That source is going to be, suppose this is 1.1.1.1. The destination is going to be 2.2.2.2. So it is going to put this information that the source IP and destination IP, which is .1 and .2 in this case, right? What we call this information? This information is known as uh, network layer header, or we call it as IP header, right? Although there are a lot of things, in this IP header, but we are not going into the detail of it. But you understand that uh, first of all, Anjali should know the IP address of Rahul to communicate, right? And the second thing is uh, every information, because we do not have the transport layer, all the information is going to network layer. Network layer is putting a header out of this whatever the data it is collecting, and then it sends it over the physical layer. Although at the data link layer is also putting the MAC addresses, and you can always argue with me that why we are using so many addresses here, IP address, MAC address, why, right? Again, just go to my YouTube channel. There are so many fundamentals videos are available, or I am going to put in Hindi as well as English. Choose your language and start learning, right? So the first thing is that this is the IP packet which is created by this network layer. Then it is going to data link layer, and then eventually it is going over this physical layer. And we know what internet is. Internet is the connection of so many networks, right? And you all should know by this time, because you are a network engineer, you understand networking, that there are so many routers on the internet, right? And how router is going to work? They just see what is the destination IP address. It is going to see the destination IP address is going to be 2.2.2, right? And then maybe if it is choosing a path from here to here, suppose there are going to be 2 paths. One path is this one, and the second path, let me showcase with another color. The second path could be this way, and this way, right? Suppose in my communication, we are choosing the path number 1, right? And if we are choosing path number 1, means if your internet has chosen path number 1, then basically every packet is going to be delivered like this, and this packet is going to be reached here as it is, right? Similarly, the second packet is going to application layer, it is going to network layer. Network layer is putting its header, data link layer is putting its header, it is putting that onto this link. The packet is again on the router 1. Suppose this is router 1, this is router 2, and this is router number 3. When it reaches router 2, here is the problem, right? At that particular point of time, when this packet don't is going from this router, right? The router was highly congested. If I'm saying congested, it means that it is sending a lot of traffic from it, right? So routers, this interface was congested. It was not able to send this packet. So this packet was dropped. So don't is dropped, right? It is not reached to the physical data link layer, network layer of the 2.2.2.2, which is Rahul, right? And if it is not reaching there, then basically don't is missed. But third packet and fourth packet reaches here, means love reaches here, you reaches here, and we do not have the transport layer. It means that network layer is going to deliver the traffic to application, and application is deliver the traffic to your WhatsApp application. If it is the case, then basically you can see the blunder here, right? Anjali is saying, I do not love you, and Rahul is receiving this message. He is pretty happy, right? So you can understand if the transport layer is not there, then this kind of problem can happen. But you can argue with me again that why network layer cannot take the responsibility? Because it is not the responsibility of network layer to check whether at the first place Rahul is there or not, right? Network layer just take the packets, just take whatever it is coming from the application layer, because there is no transport layer, it is just sending those packets after putting source and IP destination as it is. Network layer is not going to ask whether Rahul, you are there or not. It doesn't make any connection with Rahul, right? And it doesn't take care that whether if any packet goes wrong, means if any packet is missed in the network, then where it is gone. It is not its responsibility to. It needs somebody who can track every information. What are the packets? Where are they going? Right? This is the problem. And that is why we say that IP is connectionless, right? Because there is no connection at the first place. We are not going to check whether Rahul is present or not. We just see we have an IP address and we are going to send. I'm not saying that these are the limitation of IP address. I'm saying, I just want to say that this is actually this is how IP works. It's as simple as that. And that is why now by till this conversation, you should come to know that there is a need for another layer, right? Because this model is not working. If we do not have transport layer, this is not working at all, right? Whatever is the source is sending, it might be the case the packet get missed. Nobody is taking care of that. And that is why we have transport layer, right? Although you can again say that application layer can take this responsibility, but we can say that if application layer is going to take the responsibility or application is going to take the responsibility, then instead of developing that application, people are building this stack, right? They are worrying more about how their packet is going to be. It shouldn't be the case, and that's why we have TCP/IP model, TCP/IP full stack implemented, right? Now, one more example I can give you. You must be thinking that this problems is solvable, right? Even if I give an example of my wife, right? When I was creating this board, right? I was explaining her that this is the problem. Means Anjali is sending these four bits of information. Then she simply said that if this is the case, then why you can't just write mark this number with some name or something, right? If you can say this is number one, this is number two, this is number three, and this is number four, and you initially you can say that I am going to start my communication with number one, right? Then basically it is very simple that I with number one is reached here, right? Three love with number three reached here, you with number four reached here, and this device can know that there is no number two, and if there is no number two, then that's a problem. So try to understand the problem. The solutions are there, and believe me, TCP has done the same thing. My wife was suggesting, can we name these packets, right? And absolutely we can name this, but instead of naming them, TCP is numbering them, and that concept we call the sequencing, right? So my whole sole point is, if you try to understand the problem from real life, right, you have the answer for it. And believe me, these TCP/IP developers or whatever these guys are, right? They are human beings. They see problems, they understand it, and they try to solve it from the real life examples only, right? So solution is simple. Sequencing is the thing which is done by TCP. So TCP is important. You understand this, right? So these are the two things which are primary motivation for me. That one thing is basically, why do you want to learn TCP, and then why exactly TCP is into the picture. And we have learned that if TCP is not there, there can be so many problems with respect to uh, the communication, right? Now let's try to see. So let's close the chapter for now here. That Rahul is saying, Anjali, I love you, but Anjali has replied, I don't love you, and he got the message, I love you. It's a problem, right? Now let's try to see, let's try to understand first what we are going to do to learn TCP, right? We understand why we are learning this and why behind the technology itself. We are pretty much clear, right? Now let's see the approach which we are going to see. The problem is TCP has many concepts, right? Although those are very, very simple, believe me, guys. But these are different concepts like windowing, error control, checksum, flow control. So many things are there, right? So if I teach you this complete solution, it is not going to work like as it is. So what we are going to do, we are going to break this TCP into multiple problems, right? And we are going to understand these problems. We are going to understand these problems in detail. For example, in today's session, we are going to learn connection establishment and some part of flow control. If you do not know about them, that is perfectly fine. I'm just saying that when you break TCP, it is going to be break into these four parts, right? This session is going to cover some part of this and some part of this, right? Then there are some other things also like error control, congestion control. And believe me, if you are going to work on all the things together, which we generally do, and that is why we do not understand TCP well, right? So what we are going to do is we are going to learn connection establishment first. We are going to learn flow control second, then error control, then congestion control. And once we are pretty good with respect to these four pieces of information, because TCP is a big puzzle, we have divided this big puzzle into four parts. We understood those four parts, and then we are going to combine it again to understand TCP as a four. This is going to be our approach, guys, right? And believe me, I have been using this approach for so many solutions, and people are liking it, right? We have a solution which we call as software defined WAN, because if I give you a little bit idea about it, that when wide area networking, you understand where companies connect their branches with their data center in the cloud, right? It is the hot thing, right? And it has been there for longer period of time. The WAN is there for a longer period of time, but nowadays everybody is moving towards SD-WAN, and it is a short thing that in next 5 years the WAN is going to be moved towards SD-WAN. I'm not talking that everybody is going to move to Cisco solution, any solution, but SD-WAN is the future thing, right? And this is the solution. Once again, just like TCP, it's a technology, it's a complete thing which works when multiple pieces work together. So we also divide SD-WAN into multiple parts and then try to understand the multiple parts and then club them together. This should be the approach, right? So if you want to check something on the SD-WAN front, just go and see on my Bridgewire. We have a complete course on there also. And the glimpse of that course means starting 4 or 5 hours, you can see right there on my channel, right? The channel name is Bridgewire, and then basically we will be uh, giving you the link over the Telegram also. Okay. Having said that, this is going to be our approach of learning TCP. Let's move towards our number 3 board, which is how do we communicate. There is a lot of learning whenever two people makes a phone call. If you try to understand the logic behind it, and believe me, what are the various considerations we have, or what are the various things we do when two people talk over a phone, it is going to learn TCP. It is going to help you learning TCP, right? How? Let's see that. Again, we have these two characters, Anjali, and we have Rahul here, right? Very simple. They are talking over a phone call conversation, right? Anjali has dialed Rahul's number, and then basically we are, say, talking over this Vodafone network, maybe Airtel, Vodafone, nothing, right? So what exactly happens when you initiate a connection, right? When you initiate a phone call, Anjali has to dial Rahul's number. It means Anjali should know where she is going to talk, right? And that is why I said that you should know the IP address. Just like phone number is the address of your phone, right? IP address is also the address of your phone and your laptop, right? Anything which is connected over the internet should have one IP address. Okay. So Anjali is dialing Rahul's number and she makes the initial connection. It is simple, right? And over that call, basically what she is asking, Rahul is there, means hello, is Rahul there, right? So of course Rahul is there. Rahul has picked up the phone, but before making any conversation, Anjali is just want to make sure that basically if Rahul is there or not, right? So we call that basically initial connection is there. Now, Anjali is maybe explaining her the reason, explaining Rahul the reason that why she is saying she doesn't love her, right? So maybe it is going to take say 5 minutes to explain that, right? So she is talking and talking and talking, and generally, what happens when somebody talks and talks and talks over the phone? What you do? Generally, you do okay, अच्छा, ठीक है, यही बोलते हैं आप लोग, right? And whenever you say that, that okay, it means that you are saying whatever you just said, I got it, right? So you are acknowledging Anjali that whatever she has said in last 30 seconds with this and okay, you say that okay, I got it, whatever you are saying, right? Then she again talking for 1 minute, and then basically you are saying, okay. It means that there must be a mechanism in a normal conversation through which you can tell the other party that yes, you got it, whatever you are saying, right? So, and believe me, all these things are going to be converted into TCP concepts, right? So here, first we are going to learn how do we communicate, then we switch to a board where I'm going to explain how two computers communicate. But believe me, there are a lot of similarities, although there are going to be difference because we are talking about humans, there we are talking about computers. There are some differences also, but believe me, the whole soul communication principles, the fundamentals are going to be same, like making a connection, like making telling okay, so that other person other identity knows, right? Then basically what happens, for example, Anjali is talking and talking and talking, and Rahul basically she just got to know that Anjali doesn't love her, so his mind is not processing at all, right? So whatever it is saying, then Rahul can immediately say, Anjali, please stop, or can you talk slowly, because the frequency or the pace with which you are talking, I'm not able to process it. So as a human, we can say over this phone call conversation that you are talking in a pretty fast manner. My mind is not able to process it, right? Slow down. Okay, believe me, this is going to be another concept in TCP. So we have just learned connection establishment should be there, right? Acknowledgement should be there. And then basically we are just talking about that if there is a lot of information which is which Anjali is throwing on me, I can straight away say that Anjali, please slow down, right? This is the normal conversation what we do. Then what happens exactly if something or some for example, over the phone call, suppose the network was bad and some of the information get lost there, then straight away Rahul can say that I couldn't able to hear for last 2 or 3 seconds. Can you please repeat it? And basically Rahul is asking that information again from Anjali. So in normal phone conversation, we can ask if something is missing, right? What happens that what happens if this Vodafone network is busy? It is not able to take the load, right? Generally the phone gets cut, okay? Or basically if the call is there, and then the Rahul can again ask for that information, or Anjali can repeat that information because she also knows that the network is not performing well, right? So these five concepts, and believe me, whatever I write in these red colors, actually those are for me, so that I do not forget whatever I had in my mind while when I created this video. Okay, so I think you got it, that how two people communicate uh, over a phone call, because we are going to learn a lot from it, right? And see how we are going to learn a lot from it. So having said that, let's see right here. Now we are not talking about humans. We are not talking about Anjali and Rahul. We are talking about his devices, maybe the phone call. Sorry, maybe their mobile phone on which WhatsApp is running. right? And they are messaging. Although, guys, WhatsApp mechanism is such that that you send a packet, it goes to a intermediate server, and then basically Rahul connect to this and get those messages. But I really do not want to go into that because I want to make everything simple. Just try to understand that there is no server in the middle for now, right? We are having one-to-one communication. Whatever Anjali is writing on this application, it is going to reach here, right? So let's see how two computers talk over internet. So first thing first, what you need to have the address of this device. Suppose the address of this device is 1.1.1.1 and the address of this device is 2.2.2.2, right? If you are not comfortable with IP addressing, believe me, I have simplified IP addressing and subnetting in my interview preparation series again on my channel. So if you are a student or if you are going for an interview or if you want to understand the subnetting, just go through it because I have mentioned that how you can do that in simple decimal number calculation. You do not need to go into binary, right? So, but for now, basically just try to understand we have 1.1.1.1.1, sorry, so many ones, 1.1.1.1 on Anjali's side, we have IP address 2.2.2.2 on Rahul's side, right? First thing first, Anjali should know where it is going to talk about, right? So she should know the IP address. But the problem of IP address is it is just identifying this complete host. If I'm saying I have a laptop, then IP address specify this complete laptop, right? If I have a server, IP address is the address of this complete server, right? But as you know that there are many applications running inside this phone, we need one more parameter to identify that application, right? It is as simple as that you want to go to a particular person house, right? You reach to that house because you know the address, right? That address is analogous to IP address here. But once you reach at the address, you are going to say, I want to meet. Suppose there are 5 or 6 people live in there, right? In their house. Then you need to say, I want to talk to Rahul, right? If Anjali is going there at Rahul's place. It is as simple as that, right? It means that addresses are only identifying your device, but inside that device, you have many applications. To identify those applications, you need another parameter and which you call as port, right? So these applications are running on different ports, right? So if I say that this server is running a web or website, this website generally running on port number 80. And suppose WhatsApp is running on port number X, right? So IP address is the mechanism through which you can reach to that host, and port number is the mechanism through which you can reach to exact application, right? Because now my duty is not to send the traffic or my whatever the messages I am going to create to this host. That is the duty of network layer, right? Network layer is responsible to send packet from this IP address to this IP address and nothing else. I want more than that, right? And that is why I need to know what is the port associated with that application where I want to send the packet, right? Suppose I want to send the packet to port number 80. I need to say that this message, whatever is going, whatever this application is generated, should go to port number 80, right? So I need to add this extra information over this message, right? And who is adding this extra information? That we need to reach to port 80. The extra information is going to be added by the transport layer, right? So two concept, IP and port. I think you understand that. IP is the normal address and port is basically the person at that particular address where you want to go, right? But this little information which this transport layer is putting, we call this little information as TCP header, so that once this packet reaches here, these guys understand that this packet is for port number 80 or its packet is for port number X where my application, WhatsApp application is running, right? There are so many fields in TCP header, but the problem is I do not want to talk all the fields because that is going to be waste for now. I am presuming you do not understand anything in TCP, right? We will learn whatever the smaller problems, we are going to learn the smaller puzzle pieces, right? And believe me, when we understand all those puzzle pieces and when we combine them, we are going to create our own TCP header, and that is going to be similar or exactly same whatever the TCP header we have. And that is the approach of learning, right? If I teach you that this is the TCP header, these are the fields, those are not going to make any sense unless you know each and every field, right? TCP header is pretty small, means there are somewhere 6 or 7 or 10 values say, right? But those are pretty important. So first thing first, we have understood the port number concept, right? We understood what is IP address, what is port. Now let's talk about how exactly computers talk over internet. First thing first, they should know the IP address, they should know the port address also, right? And that is why there are well-defined ports for websites, which is port 80 for SSL website, or there are so many applications like and there are so many questions which comes on the certification on which port protocol DSCP work, right? On which protocol number, or what is the protocol number or the TCP number, TCP IP port number for your file transfer, which is FTP, right? You get so many questions like this. So you understand the port pretty well. I believe you understand that. Right? Okay. Now, first thing first, what exactly TCP does? TCP checks whether the other party is there or not, right? And that is what we call as the connection building, right? TCP say, hey, Mr. Rahul, are you there? Okay, let me draw from here to here. Hey, Mr. Rahul, are you there? And if you are there, then I am starting sending my packets from number one, right? I'm not going into the concept of sequencing now, but just try to understand that first thing first, uh, TCP is saying, I want to send a packet to you, right? And whatever the packet I'm sending, it is going to having a number one so that you know that, okay, Anjali is starting the conversation with that packet, right? Where exactly this number should go? This number should go also into this header, right? That it is going to be starting, and that number we generally call it the sequence number. And where that information is going to be, it is in the TCP header. So what should go into the TCP header? First thing first, the port, right? The second thing is sequence number. It should go, right? And once this guy, Rahul, receives this information that Anjali is sending, say, hi, I want to start a communication with you. Here is my sequence number. Rahul is going to reply, okay, Anjali, I confirm that I am here and I agree that basically you are going to start from number one. Okay, there is a connection first. The second message which Anjali is going to send is with 2, with 3, and with 4. Now, because Rahul knows that the packets are going to be in this order, number 1, number 2, number 3, number 4, the transport layer at Rahul understand if something is missing, suppose if this packet is missing, transport layer is not going to deliver this information to Rahul's phone unless it receives all the messages. I am oversimplifying things, but this is actually happens, right? We are going a little bit deeper into this, and I'll make sure that when we are closing this conversation, whenever we are closing this conversation, I will make sure that you see each and every packet which I'm talking about, right? So right now, basically how to computers talk when they are using TCP. First thing first, there is going to be a connection in which Anjali is saying that, hi, Mr. Rahul, here is my sequence number. I want to start from this sequence number. And Rahul is responding back, okay, perfect. Okay, this is the thing. And I'm presuming some of the things that you guys understand network data and physical layer. If you are not, then let's try to understand what exactly happens. So transport layer, basically, this was the data which we got from application. And this is the extra information which TCP is building to have that connection built, right? And believe me, the lower thing is again the internet, the same thing, which doesn't know about connection establishment. And that is why you need something on top of transport layer, which is talking. You can again argue with me, what happens if this the first packet is missing, where you are sending, where you are saying that, hi Rahul, I am beginning from number one. This can happen because this first packet can right be drop here, and Rahul cannot get that message at all, and it cannot start the conversation. The solution is simple, right? If Anjali is waiting for some time that okay, there is nothing coming from the Rahul side, she is going to send this packet again. It is as simple as that, right? But we are making sure that over this IP, we are making sure that there is somebody who is getting the connection. It is as simple as that. Okay. So this data which is coming from the transport layer, TCP is going to add some header information to it, which is port number 80. Suppose it is talking over the port number 80 and sequence number 1. So this we are calling as TCP header, right? Now, when this information, this complete information is delivered from transport to network, network layer is going to put more information, which we call as IP header. It is as simple as that. And the IP address is going to put 1.1 as a source IP address and 2.2 as a destination IP address. And I'm again saying that there are so many fields there, right? As a network engineer, if you know them, that is perfectly fine. If you're a student, if you do not know, that is also fine. But we are going to talk about the most important field, and the most important fields of the IP header are source IP and the destination IP. I say that routers work at layer 3. It means that they understand till layer 3. When this packet moves to this router, it is going to check what is the destination IP address, which is 2.2.2.2. Then it sees into its routing table and forward this message out of either this port or this port, whatever the routing table says, right? It is as simple as that. Now, the another thing is basically there is one more thing. When this IP or the network layer send this information to data link layer is also again putting some information, right? It is putting the source MAC address and the destination MAC address, right? So this way, at the sender end, that information is flowing like this, right? And then basically over the physical layer, it is going in the form of ones and zeros, right? So if I consider the IP header or if I consider the IP header, then whatever the information in this white header and this red, everything is data for IP, right? If I consider layer 2 or the data link layer, whatever I have written here from here to here, it is data for it, right? For the data link layer. And the process, whatever we are explaining here, is called, by the way, guys, encapsulation. We are encapsulating the application data into TCP, then we are encapsulating TCP into IP, and we are encapsulating IP into this. And believe me, we are exactly going to see everything on the WireShark. So if you do not know about WireShark, WireShark is a tool through which we can capture whatever going over these wires. Whatever going over these wires, I can capture them. I can see exactly the TCP header, the IP header, the data, everything we can see if it is not encrypted for sure. Okay. And this is a great tool in learning networking. We are going to showcase you. Do not worry. But now, by this time, I think you understand that how traffic flows at the sender side from application to physical. When this packet, the entire packet reaches from here to here, the data link layer reads its source MAC, data MAC, destination MAC, and then and remove this part of the information. It moves this packet here. The network layer see this packet is for me. I am 2.2.2.2. It removes it here, and we are calling all this process as a decapsulation. And then basically it goes to network layer, and then it delivers this information to transport, through which it knows that okay, it is the port number 80. I need to send this message, and then basically the sequence number of this packet is 1 because I have specified the sequence number in TCP header, right? The packet is delivered to the Rahul's application on which it is working. So network layer responsibility is to make sure this packet is reached here. Application layer responsibility is just to send the packets, whatever it is coming from the application, and send it to transport, right? Transport layer responsibility to make that initial connection. Network layer responsibility is to send the packet from source to destination, but where exactly it should reach to destination is the responsibility of transport protocol, right? We are recording this sessions, guys, right? So do not worry about it, that uh, if you miss something, you can see that again. But for that, to get that recording, what is the procedure? I will be telling you at the end of the session, right? Having said that, we are talking for last 50-60 minutes. Let's see what we have in the next board. Let's complete that board, and then what I will do is I will open this session for some of the questions for you, right? We will take few questions which are very important, and make sure, guys, if somebody else is speaking, you just go on mute, right? Because right now there are 55 people in this meeting. If you all start at once, it is going to be a problem, right? But do ask questions. I'm not saying that you should not ask questions, but if somebody is asking that, then please refrain yourself, on put yourself on mute. Okay, so having said that, let's understand, let's introduce some terms now, right? And I am pretty sure that you get to know whatever I'm talking about, but let's introduce terms, because terms are important. Why terms are important? Because whenever you are going out for the interview, and if somebody is asking about flow control, you should know, you should understand what flow control is, what checksum is, right? So let's define the term. First thing first, when transport layer is saying that if there is anybody at the destination, right, we are talking about TCP connection establishment, which is a three-way process. And I'll show you that it is a four-way. But do not get confused. We will be talking about it, right? And then Anjali say that I'm marking my packet, and the initial packet number is going to be 1, right? That is just nothing. That is the sequence number concept. You are doing sequencing of these packets or the frames, right? If this guy, Rahul, says, okay, if I'm relating with that conversation, if Rahul is saying that, okay, I receive your message, you are doing acknowledgement. This is acknowledgement, right? So sequence number, concept of acknowledgement, connection establishment, these three things we have covered. Now, the other thing is Anjali is showing a lot of information to Rahul, right? So much data to Rahul. Maybe Anjali's mobile is so fast, but Rahul's mobile cannot process that too much of data, right? What we can do, we can make sure, we can say, Anjali, please do not send me 1 terabyte of data. Send me few million bytes or maybe kilobytes, right? So this basically, the process is known as a flow control, because I am controlling the flow of what should I receive, right? Anjali is throwing so much information on me, and I can guide Anjali's that please stop. Send me only this amount of data, otherwise I won't be able to process it. And all the things which will come into this category are not going to are known as flow control. And here you are going to see the concept of buffers and the concept of windowing. And believe me, I still do not know why windowing is so much difficult to understand. Believe me, it is one of the most simple concept if you know that there are two streams going on, right? And I'm going to simplify that windowing thing for you, because it is asked everywhere, right? So under this flow control thing, we are going to understand buffering, windowing, and then basically how this window expand or shrink. But pretty easy concept, very easy concept, right? Sometimes this message gets lost here, right, on these routers. It means that we are not able to get the message, whatever Anjali is saying. There is an error somewhere. How we are going to make sure that this error is controlled, and that is going to be your error control mechanism, where we are going to talk about checksum, or where we are going to talk about the acknowledgement in which we can send the information that I have received this much of information. I want this information from you, which is implemented as selective acknowledgements. We are going to talk about it in that error control thing, right? Then congestion control. Congestion control means what if this complete network is having so much of data that it is not able to process few of the things, right? Then it is the responsibility of Anjali to check that yes, network is congested. I should send some less amount of data, right? Otherwise, my data will be lost. So we are going to read that congestion control, where you are going to learn that those algorithms like TCP slow start and all. But believe me, if you understand why do we need all these things, this is a requirement of normal phone conversation. This is a requirement of normal conversation where two computers are talking, right? So if you have that bigger picture in your mind that, okay, if Vishnu is talking about flow control, he's talking about that Anjali is showing so much of data and Rahul is saying, no, I do not want it. How they are going to implement, that is a separate thing. But believe me, those are again from the real life examples. Absolutely. Okay. So by this time, basically, you understand some of the terminology: flow control, error control, congestion control, right? Sequencing, acknowledgement, connection establishment. We are going to talk about them in greater detail. But having said that, we are talking for last 1 hour. Let's open for this bridge, this meeting for some of your questions, right? So just give me some time, guys. And I would say just make your hand raise, right? And I will ask questions. So first question is should be from Apurv Datta, right? Let me giving you an option so that you can talk. Just wait a minute. Yeah, now guys, you can talk. Yeah, Apurva. Perfect. It's a great question. So let me guys, please be on mute. Whoever is not talking. Otherwise, the session is going to be messy. So as I mentioned, Rahul, Apurv, Rahul is always there, right? So let's talk about this. This is good, right? So when I was explaining you this header, right? So suppose this was my IP header. Suppose in IP header, there is a field, Mr. Apur. I haven't talked about all the fields. Why we just talk about source IP address and destination IP address, and exactly there is a field which says protocol, and where we write exactly TCP or the number associated with. I forgot the number, but there is a number. I think 1670 is associated with TCP, right? This number, the protocol type, right, explains that this is the TCP, sorry, this is the IP header. But what exactly after that TCP, IP header is the packet which is TCP, right? So protocol type field defined in the IP header. If you define IP header protocol type field, it is just letting you know that what you need to expect inside this IP packet. There is going to be TCP, right? And if I talk about taking an example from uh, this guy, right? Data link layer, right? This one. There is a field called ether type there, right? And you can specify there what exactly in this, because you are going to encapsulate this complete packet. So nobody knows what is exactly inside it, and that is the way, that is the way how you can define it in the ether type field. If you go right here, you can define that that the packet inside is the IP1, and we call that a protocol type. But the port number which we are talking about is the field in the TCP header, which is saying that when you reach to destination, this message is for that particular application which is running at this port. So I think you get the answer, Apur. Anybody else? No, that. So I got your question, and it's again a Kushal, a good question. So the question is, guys, that how basically if two applications are running on this guy, Rahul's I mean, Telegram is also running, WhatsApp is also running, how you are going to identify? No two applications, right, can run on the same port. If they are doing, then for example, if you are running and we are taking exactly the wrong example, WhatsApp and what, for example, if we take the example of web server or FTP, right? You can say the web server is running at port 80. If web server is running on port 80, no other program can run on port 80 because it is blocked. And this port 80 is well-defined number for web application. Similarly, FTP is also. So this is not the case that FTP is also run. Otherwise, there is no difference. So the problem is, I can take the same example. If you are going to a particular house, right? And then basically you find that there are 5 people with the same name. It is not going to work if you say that come this side, all 5 will be there, right? So no 2 application will be running on the same port for sure. Similarly, at the source also, whenever it generates the packet, so I have mentioned only the destination port. Whenever there is a communication, source also open a port so that destination can talk to it, and those ports we call ephemeral port. We are going to cover that. But to answer your question, no two applications are running on the same port on the server side. Anybody else? No problems. Yeah, go ahead, Akshay or Surender. Go ahead, please. Yeah, two different. So the question is basically, suppose this there is a Google server and there is a Amazon server who both are running at port 80, right? And I am here. How I'm going to communicate with the port 80 with both the server, right? So believe me, that is why I am saying that there is another parameter which I mentioned, that when source open a connection, suppose source is opening a connection to this port 80, suppose at the Google server, right? So what it is going to know, it should know the Google server IP address, one thing, which is the destination IP address. It should know the Google server port, which is 80. Perfectly fine. You understand this. It also should know the source, which is IM. So suppose this is Anjali. It should know the Anjali's IP address, which I know. And when it opens the connection, it opens the Anjali port also, which is some large number, ephemeral ports, say 1, 2, 3, 4, right? So this is the one socket. So this is the one connection which is identified these 4 parameters. Now let's see how Anjali is going to open the connection with Amazon server, right? Again, the Amazon IP address is going to be different, right? Amazon port is going to be same. Anjali's IP address is going to be same, but Anjali's port number is going to be different. So this connection is completely different. This connection is completely different. You're getting my point? You got it. Thank you so much. So anybody else? Let's talk about. So I think there is a question from Akshay also. Actually, let's leave it for now because we are talking something which we are going to cover in the next session. But believe me, there is a difference, and we are. So basically, the question was, how is flow control different than that congestion control? We are going to discuss it. No worries. We are going too far. Anybody else? How is it? Means in Amazon, if you go to just try to ping Amazon console or Amazon Google AWS, or try to ping Amazon.com. Those are on different IP address. But yes, inside the Amazon, you can have the various pages. And for that, basically, we are going a little bit off the track. We need to understand HTTP for that, right? We ask something in the same IP address. It doesn't mean that on that particular IP address, you can have only one page. You can have multiple pages, right? But you specifically ask that information. Now I am talking about this product. I am talking about this product. Give me information about that. But it should not be the case that the Google and Amazon are going to be having the same IP address. So that is why basically, so question is basically, if you have opened a port 80 website, how you are going to say that I want this web page or this web page, right? So that is why there are links, guys, right? You have, suppose you want to buy a cricket bat there, right? This is product number 1, this is product number 2, this is product number 3. This complete information is given to you by whenever you say get Amazon web page, you will get all these things. Now it is up to you what information specifically you're asking. If you click on this, you are going to get second web page information. This is again, we are deviating from the topic. This is not TCP. This is simple HTTP. Just maybe we can have a session on that. But for now, let's not go into that. Okay. Now, anybody else? Yes, yes, yes. So basically, guys, your voice is not going to be there with in this recording. So I refrain to means if you answer the question, nobody is going to hear in the recording. So I'm extremely sorry, but your explanation is correct. Yes, there are website pages. Whatever information you need to click it. But again, that conversation is basically of what we can say. The conversation is going towards HTTP learning and not TCP. So with that. Because I need to cover a lot, I will open this channel once again. But for now, what I'm going to do is I am again putting you all on mute while going into the meeting options. Just give me a minute time, and I will again open after maybe a 45 or 1 minute. So be here. Okay. So let's start for our next board. Again, we have introduced some terms. This is perfect. And now let's talk about problem of a missing packet, right? That was the problem. So believe me, guys, these characters are going to be with us in explaining error control, flow control, congestion control, everything, right? It is going to be there. These characters are going to be always here. So if I talk about problem of a missing packet, you understand that problem of a missing packet, that this packet was there at the receiver, this packet was there, this packet was there, but this packet, the don't, was missing, right? And we try to solve that. Can we do something? At least can we take some steps by putting transport layer? And why this problem was happening? Because there was no transport layer, right? So we need to understand now what exactly transport layer is solving this problem. And believe me, as I mentioned, that you all, means even a 10-12 years old kid now can say that just write the number of them in these packets, whatever are coming, 1 2 3 4, right? So that when and tell the receiver that I am starting from 1. This is the thing you just need to do, and that is exactly what we are going to do. That is exactly what TCP is going to do. TCP is going to initiate a connection, right? TCP is going to initiate a connection in which it is going to say, I want to start from packet number 1, although this number can be anything, right? And that is why basically this sequence number is a 32-bit field in TCP header. And from 1 bit, you can come up with 2 combination. With 32 bits, you can come up with 2 to the power 32. You know, this number is huge, right? You can begin from any number in TCP. But for simplicity's sake, we are saying here, just mark them 1, 2, 3, 4. And once this information is reaching here, this guy is going to see 1 is there, 3 is there, 4 is there, but no 2. And TCP makes sure that I am not going to provide the information to Rahul's application unless that information is complete. Okay, you're getting my point? So this was a problem of missing packet, we all know, and that is causing a lot of confusion. But no, you understand that although Rahul and Anjali was talking after this conversation where they missed, so the problem is solved now because they had a phone call. But can we solve this problem from the IP packet, from the in IP network using transport? And that is going to be the discussion of this complete session, today's session. We are going to make a connection. We want to make sure, first thing first, if Rahul is there or not, right? And if Rahul is there, we are going to say that I am going to start the conversation with this number, so that Rahul is aware that, okay, this number I should expect in the TCP connection. And it doesn't matter now that whether this IP layer is connection less or not, right? Suppose I am sending this first packet that in which I am saying that I am going to start from 1. Rahul, you there? It is simple question from the Anjali's side, right? and suppose she doesn't get any reply, it means that whatever the route, or it can have two options, right? Whether this message is dropped somewhere, the first packet is dropped somewhere, or Rahul has replied and that is dropped somewhere, right? Only two options are available. So if Anjali can start a timer here, say for maybe say 30 seconds, that if I do not hear back from Rahul, I am going to send this packet again. That hey Rahul, you there? I'm going to start with one, right? So it doesn't matter whether my underlying protocol is connection oriented or connectionless. I can make a connection on top of it. It is as simple as that. For example, I have, because you are network engineers, everybody, you understand mainly from routers and switches. Suppose we have these routers, R1, R2, R3, and R4. And suppose these routers are connected, right? But the problem is, over these two routers, I do not have control, and I want to run routing neighborship between R1 and R2, maybe R1 and R4, maybe OSPF you want to run. What you exactly need to do that? You need to connect R1 to R4 because you want them to be directly connected, right? If you do not do that, then there is not going to be a OSPF neighborship. So what you do generally, you create a GRE tunnel, right? This is a virtual thing, right? It doesn't mean that R1 is connected to R4. This is virtual. And how you are building this virtual tunnel? Over this network. But it is giving you a sense that R1 and R4 are directly connected. Similarly, here also, this is just my infrastructure, the IP, who is delivering the packet. But I am going to create a connection between this TCP to this TCP. If I am saying this TCP to this TCP, the meaning is from source TCP to destination TCP layer, right? This is a virtual connection. It is not the case that I am taking a cable from Anjali's mobile phone or computer and putting it directly to the Rahul's computer. It is not the case. Because there are so many router and switches over the internet, I cannot do that, but I want to make a connection oriented service over this connectionless service. How I can do that? I can do this virtually, and I can I can just do that. Mr. Rahul, you there? He's saying I am here. Anjali is saying I am going to start from number one. This is just the connection establishment, right? So because IP layer was not able to do it, that is why we are introducing TCP layer, which is creating this connection. It is as simple as that. Okay, so having said that, let's talk about connection establishment and why it is important, right? So I think you get the concept here, right? Now I do not have any transport layer again. You can see here. IP is connectionless. We know that. IP's responsibility is to take the packet, whatever are coming from the upper layer, maybe transport layer, and send it to data link layer, to physical layer, and then basically send it to here. It works on the best effort that if everything is working fine on these routers, the packet is going to be delivered, otherwise not, right? But if something gets missing here, this is not the responsibility of IP to send that packet again. If it is not the responsibility of IP, which we were also talking about, right? We were also talking about that as a network engineer, our responsibility is still network layer, right? So whose responsibility is this? The responsibility is of the transport layer. If we introduce the transport layer is going to build a TCP connection between source TCP to the destination TCP, and how it is going to work, how it's going to do that, we are going to understand it, right? But I believe by this time, because this is a problem of so many people, whenever they have been asked that how you are going to make a connection over a connectionless service, they get confused. Guys, try to understand this connection is virtual. It is giving you the sense that yes, this guy, not the sense, this is giving you the confirmation. Yes, the other guy is there, which was not there in the connectionless service, right? you can create a connection oriented service over connectionless service pretty easily, right? It might be the case that you have to send this packet again and again if this message is lost, but you can create this connection. And this connection, we are going to go into deeper. We are going to see what exactly the message Anjali is going to send in a real protocol. What exactly happened, how TCP is going to make this connection. But first thing first, you need to understand why we are creating this connection. So by this time, I am again saying you should understand. If not, then probably you need to stop right here. Just get a cup of coffee, right? Whenever you are going to see this recording, just get a cup of coffee and go through this presentation again. Believe me, till this point, if you do not understand why connection is required, then there is some problem with my teaching or there is some problem in your understanding, right? Telegram group is there. Just write the problem there and I'm sure that somebody is going to answer or even I'm going to answer. Okay. Having said that, let's move to next board where we are talking about connection establishment and why it is important. We have talked about it, and I'm not sure why I have this board again. But here I want to introduce few terms actually for the connection establishment, right? So we were talking about this TCP means this data which we get from the okay. There is data which we get from the application. So this is the data. And what we do, we just put the TCP header on top of it, right? So TCP header I have showcase you with white color. So here you go. I put this TCP data, TCP header. So this is going to be my TCP header. Now I want to talk about few things here. You understand that we need to define port here in this header. And by the way, apart from this, this is the for TCP, this is only the payload or only the data information, right? So whatever the data it is getting from the transport layer, it is encapsulating it into the TCP header. It is just putting a header at front of it, and we call this complete thing as TCP segment. The concepts are going to be really important, so please pay close attention. Now, what this TCP header contains, we are going to talk about only important thing for this session. You already understood that there is a port value there, right? And port are going to be two. One is source port and the second one is destination port, right? Destination port is always be definitive. For example, all the websites run on port 80, FTP run on, you can fill this board anytime, right? DSCP DNS works on some port, but those are basically DNS is a UDP based, so let's not talk about it. So port, we are going to have source port, we are going to have destination port. Destination port is fixed, but whenever this guy is opening a connection with the Rahul, she is opening a port so that the destination can communicate back, right? That is called as source port, and we call such ports as ephemeral ports. What is the meaning of ephemeral? The meaning of ephemeral is that these ports are changing ports, frequently changing ports. So for example, if TCP, if Anjali is initiating connection with a Google server, suppose, right? And if she has open 1245 port number as a source port, then if she terminate this connection and initiate a connection again with the Google port, it is not the guaranteed that we are going to get the same port again. This port is chosen by TCP. There is a specific range. You can go and search on internet what is the specific range on which we can have this ephemeral port number. But yes, for the destination port, everything is fixed. I am pretty bad with the port numbers. I do not remember them. And you means it is up to you. You can remember them, but there is no point. Okay. But I remember port 80, port 4443, which are very, very important. Okay. So having said that, TCP header, first thing which is important is port, which is identifying the actual application on the destination and the source. Now, what are other things? This TCP header some also has some flags. Now, what is the meaning of this flag thing, right? We need to understand it, right? So I will give you an analogy. I will give you an example. So if you are in India, you must have gone through many restaurants. So there is a restaurant in India, right, which is pretty good. Means in terms of serving the starters, I am a foodie, so basically it is very good restaurant, right? So what they do is they put a flag on their table, right? And if this flag is on, if this flag is open, right? If I'm saying it's open, it means it's selected. Then basically all the uh, guys who are serving us, who serves us food, right? They see the presence of this flag, whether this flag is up or this flag is down. If this flag is up, then basically the waiters or the guys who are helping us with the food, they knows there is a common understanding that if this flag is up, it means that I need to serve more food or more starters, right? But after some time, after half an hour or 45 minutes, if I'm done with those starters, what I can do is I can make this flag down, right? And after seeing this flag down, this guy has a feeling that okay, the flag is down. It means that the people who are sitting around the table are just full with their starters. I do not need to serve them. It means that a flag is there to indicate something. A flag is there to transfer some information to you. A flag is there to convey some message to you. Similarly, in TCP, we have flags. There are 5 or 6 flags which convey some message, right? We are talking about two of them to begin with, right? But the point here is that these flags can have only two values. Either they can have up or they can have down. In computer science, basically up is represented, or basically you can represent with anything, but in computer science, basically this state of up is represented by 1, and if that flag is not enabled or flag is down, it is represented by 0, right? So if in a particular TCP header, if I say I have a flag which is up, it means that I am saying the flag value is 1. And then the TCP header has some specific meaning. And what is the meaning of it? For example, I have a SYN flag there in TCP. If its value is 1, then basically this complete TCP message is a SYN message for me. And SYN is a short form of synchronous message. Why we are going to learn about it, it is very important. But you try to understand the concept of flag, right? It is just nothing. Just take an example from the real life. If this flag is up, it is indicating something. And there is a common understanding between me and the guys who are serving on my table that if this flag is up, you need to serve more. If this flag is down, no problems at all. I think you get my point. Okay. So similarly in TCP header also, we have some flags and they have some important meaning. If the flag has SYN value is equal to 1, it means that it is a synchronous packet. I should understand that it is a synchronous packet or SYN packet. Similarly, I can say that there is another flag which is up. So there are 5 or 6 flags. There are 6 flags to be precise in TCP. And this, if this flag is also up, I can say, and suppose this is a ACK flag, right? Which is also 1. I can simply say this is my SYN plus ACK message, right? So now the question comes, and the question is pretty easy. That we have TCP header, we have understood that there are some flags in it. We have understood that there are some ports which are source port and decimal destination ports, and there are some numbers also, guys, here. And the first number is the sequence number. What the sequence number is and what it is significance, I think I have mentioned you that if I have to send these 5 packets to Mr. Rahul, I will be marking them with a particular number, right? So this number is also a specific field in TCP header. This is not a flag, guys, right? Just like port number, destination number, we have sequence number as a part of a field in TCP header, which represent a number and the value is 2 to the power 32. You can have any value, right? So basically, we can mark the packet with the sequence number. Marking of packet is important, right? Because we understood that if this packet is gone, then transport layer at the receiver side is going to understand this without any problem. That packet number is 2 is missing. It is as simple as that. So I'm just repeating once again what we have learned here on this board. We have learned that there are some flags who have some specific meaning if they are enabled on a particular header inside a particular TCP header. It has some specific meaning. We are going to discuss that specific meaning. Do not worry about it. We make sure that flag also contain the port numbers, right? And those port numbers are very important because they identify the application on the receiving side and on the source side also. We also understand that there is a 32-bit value in the TCP header, which is the sequence number. We use that sequence number to sequence our packets, right? But is the sequencing is this much easy? Absolutely, it is this much easy, but in TCP there is slightly tweaks around the sequencing. If you know numbers well, 1 to 100, and everybody knows number from 1 to 100. If you know them well, if you know addition, subtraction, understanding TCP sequence number, understanding TCP three-way handshake is going to be as simple as that. But you try to understand that there is a concept of flag which indicates something. There is a concept of port number which identify a particular application. And there is a concept of sequence number which identify a particular packet of the TCP flow. Having said that, let's move to new board, which we have here. And we are talking about concept of sequence number here, right? So what I'm going to do is I am going to write this big packet here, and then basically there is a data which is coming from the application, right? Although it should be other way around, data should be more, right? This packet, but we are going to understand this TCP header. This is your TCP header, guys. That is why I am writing this, right? So there are going to be some flags here. That is perfectly fine. And then there is going to be some more information. The first information we are going to talk about is sequence number. Very important concept, right? And what Anjali can do is to Rahul is whenever they initiate a connection, she says that I am going to start from number 1 and I am going to start marking my packet with number 1. Number 1, number 2, number 3, number 4. And once you reach there, basically, and once Anjali informed Rahul, Rahul is expecting packet from number 1, right? So this packet is received with number 1. Rahul is happy. 3 is again happy. 4 is again happy. He is happy because he didn't receive don't, right? But actually, the transport layer is intelligent enough that it knows that there is no packet number 2, and that is why the problem. It is not going to give this packet to this guy's application, and that is why the sequence number is important. We sequence packets in TCP, right? Again, I'm repeating whatever the data I am receiving from this application. This is a continuous stream of data. What TCP does, TCP create a meaningful information out of, not the meaningful information, it just chunks the data into different segments, right? So basically your transport layer is receiving information from top, from your application, which is a continuous stream of 1 and 0, right? TCP responsibility is to chunk them, is to divide them into a particular format. And we call that format as segment, right? Then TCP put this header on top of it, put the port numbers and put the sequence number value also, right? So TCP gets the data, create a header, put that header and then send this information, so that when the transport layer of the receiver gets it, it knows that, okay, this is for application WhatsApp or my website, and this is the number one, and I was expecting number one. He's happy, right? Sequencing is important because this way you can track packets. But now let's see how sequence numbers are there in TCP, which is again a very important concept, guys, right? So you have a application layer here, and you have a transport layer here. You are getting data from transport layer, sorry, application layer into transport, which is as simple as that, right? But this data is coming into the continuous stream. There is a huge data. Maybe you are receiving the data from application in many kilobytes or megabytes, right? So TCP is doing something different here. Instead of marking a complete packet or complete segment with one sequence number, maybe one or two, right? It marks or it sequences every byte of information, right? So suppose this app is sending 10 bytes. By the way, guys, I know you all know, but I'm repeating. 1 byte is equal to 8 bits. So whatever the TCP is receiving from the application, it is taking those 8 bytes from the application and marking them with a sequence number. So here you can see byte 1 is number 1, byte 2 is number 2, byte 3 is number 3, and so on, right? And there is a field. So I am again expanding this TCP header, right? So we are good till the point of port numbers, we are good till the point of sequence numbers, we are good till the point of the flags, right? There is a field in the TCP header which is a length field, which specify how many bytes of data we are having in this segment from the application. So suppose this is a 10 byte data, right? So I can mark this number as 10 as a length field. So if the length field in the header says that its value is 10, it means that I have received 10 byte of data from application and I'm encapsulating it in the TCP. It is as simple as that. So this is your data, guys. And TCP has marked every byte of data with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So can I say if I want to put the TCP header, because this is my data, this is simply my data. Now I get this data at the transport layer. What TCP is going to do? TCP is going to put its own header here, right? In this header, it is going to say the length is equal to 10. If somebody is reading this TCP header from here to here, without looking into the data itself, not 0, it is 10, without looking into the data field itself, by looking into the TCP header field, I can make sure that this packet, whatever I'm talking about, is of having length 10, which means that the data I have received from the application is 10 byte long, or there are 80 bits of data. It is as simple as that. And then TCP starts marking them with a sequence number. Byte 1, it is going to mark with 1. Byte 2, it is going to mark with 2. And similarly, byte 10, it is going to mark with 10. It is as simple as that, right? So inside a TCP header, whenever you see length 10, it means that there is a data in this segment, and the data length is 10, means 10 bytes of information you got from the application, right? Now, what should be the sequence number? Here is the problem, right? Because I have so many sequence number here, right? Byte 1 is represented with 1, byte 2 is represented with 2, similarly byte 10 is represented with 10. What should be the sequence number of this packet? The sequence number of the packet is the first sequence number which TCP used to mark a data into a particular segment. So first byte is 1, right? So having if you know these two values, or if anybody knows these two values, you can straight away calculate what is the next packet going to be, or next segment going to be, right? For example, if you say here my sequence number is 1, right here you can see, right? And the packet length is 10. It means that TCP is marking from 1 to 10. Now more data comes, right? Byte number say 11 come, byte number 12 come, and TCP is going to and suppose 13 comes, 14 comes, 15 comes, right? What TCP is going to say, that this packet is filled, this packet is over, I am expecting a maximum length of 10 bytes, say, right? Now TCP is going to create another packet or segment for another data which is coming from the application, and then basically this byte 11, byte 12 is again going to be marked. Can anybody tell what is the number from it is going to start? 10 is already there. It is going to be sent as a stream, right? So it is going to start right from 11, again 12, again 13, again 14, and this 15, right? Because 5 bytes it has received from the application, right? So if I make a packet out of it, and then it is received at the if it is received at the transport layer, then we are going to put the TCP header. What is the length of this packet segment? The length is going to be 5. Why 5? 1, 2, 3, 4, 5. And where is the sequence number? 11, 12, 13, 14, 15. It is as simple as that, right? So what is going to be the sequence number of this segment? It is very simple. As I mentioned, the first sequence number is going to be the sequence number, which is going to be your 11, right? So TCP header contains a value of sequence number which indicates that this is the number where I am marking my first byte of information which I am receiving from the application. It is as simple as that, right? So if you add these two numbers, if you add sequence number plus length, what you are getting? You are getting the sequence number of next packet. It is as simple as that. See, suppose this is your first segment of TCP, this is your second segment of TCP. I'm taking an example of first segment of TCP. Sequence number is just 1, length is 10. What is the next sequence number of the next packet? It is going to be 1 plus 10, which is 11. It is as simple as that. Take an example of second segment. What is the sequence number? The sequence number is 11. What is the length? 5. It means that 11 plus 5, 16. The 16 is going to be the next number which TCP is going to mark. You must be thinking that why Vishnu is teaching us so simple things, so simple mathematics. Believe me, this is where people get confused, right? If they see large number, they see that, but the problem is, it's the problem of just addition. Doesn't matter if you are adding two small number of or large number. If you know addition, right? Very, very simple concept. I think you understand what is the meaning of sequence number, how we mark it in TCP. Just try to make sure, just try to understand every byte, whatever we received from application is going to be marked. But again, you should start thinking from the perspective why we are doing it, why we can't mark the complete information whatever we are receiving, right? And believe me, we are going to understand this. We are not going to so many complex things in the first session, but I strongly believe this is not complex at all. Okay, having said that, let's move to our new board, which is the concept of acknowledgements. It is simple. Once again, the concept of acknowledgement is simple. Why? Because this is as good as you are talking to somebody and he is replying back, okay, okay. So let's see what actually I'm doing here. See, we have again Anjali, we have again Rahul. Anjali is sending a first packet or first segments toward Rahul. Its sequence number is 1, length is 100. Very good. It means that if the sequence number is 1, then the basically length, there are 100 bytes. 1 byte, 2 byte, 3 byte, 4 byte, just like we have 100 bytes here. So first byte is marked with 1, and that is why Anjali has written sequence 1. Anjali's TCP has written sequence number 1, and the length of this packet is 100, and that is why basically length is 100. So what is the next packet going to be created by Anjali? The next packet is sequence number 1 plus 100 is equal to 101. And that is what Rahul is saying. Anjali, acknowledgement 101. What is the meaning of this acknowledgement 101? The meaning of this acknowledgement 101 from Rahul's side is that Rahul has received information till sequence number 100. But where is the sequence number 100? Sequence number 100 is the 100th byte which you have marked with sequence 100, right? If I am saying sequence 1, length 10, 100, it means that TCP has marked all the 100 bytes of information, and the last sequence number was 100. And that is why Rahul is saying, I got till 100. I am expecting next packet as 101 from you. It is as simple as that. Okay. So when Anjali received the acknowledgement from Rahul, Anjali sees, okay, 101 is received. Okay. Now what Anjali is saying? Anjali is saying that I am sending you another packet whose initial sequence number is 101 and the length of the packet is 200. Right? It means that TCP start marking length 200, 101 is for the 201 byte of data. Sorry, 101, it is going to mark 101. Similarly, right? And once Rahul gets this message, it is going to reply back that acknowledgement 301, which says it has received till 300 bytes of data and it is expecting the 301st. It is as simple as that. So if you have sequence and length, if you know them, you are good to go, right? You are good to go in acknowledging the packet, because if you add these two numbers, which is a 101 and which is the what you are expecting next, and that is going to be the next number, which next number of the frame, next number of the segment which Anjali is going to create. It is as simple as that. Okay, simple. Now let's see what we have learned in this TCP header till now. We have learned some flags are there, right? Some flags are there, and believe me guys, the next conversation, next few boards are going to be very, very important, because whatever we have learned in last 2 hours, we are going to see them. We are going to see how actually everything works. We are learning sequence number, we are learning acknowledgement, right? But the important thing is combining together. But if you have spent time till this point, do not forget to spend time 1 more hour, right? If you want to go for a break, I can take a break of 5 minutes, but maybe it is going to maybe we can ask questions for 10 minutes. Just let me explain the two boards and we will be open for the questions. Do not worry. Okay. So having said that, if this was my TCP header, right? What I have learned till now, I know some values in flags, right? I know that there are port numbers. I know that there is a sequence number field, right? And I also know that there is a acknowledgement number field, or X. Guys, sequence number field and sequence number flag is different. I see a lot of people get confused in this. Acknowledgement field and acknowledgement flag is different. So we are going to learn more about sequence flag. We are learn about ACK, because these are important in creating a three-way handshake. Similarly, port number, you know, sequence number is a 32-bit field. right? Acknowledgement number is also a 32-bit field because it is acknowledging the sequence number, whatever you are saying. Very easy. So we are not going to look any deeper into the TCP header than this. If we know flags, if we know concept of port numbers, if we know sequence numbers, acknowledgement, we are, and one more thing which we are forgetting, guys, the length field. So there is another field here, which is your length field, which is specify the length of the data which we are receiving from. So if we know flags, if we know port number, if we understand sequencing, if we understand acknowledgement, and if we understand concept of length, we are ready to understand TCP three-way handshake. And the problem is the most of the guys start with three-way handshaking. Believe me, whatever we have discussed till now in last 2 hours, that base is required. And I'm pretty sure if I don't teach you the TCP three-way handshake, you can understand. You just go and read any book. You just go and read any paper on internet. You will get everything out of TCP handshake. But this base is really, really important. Similarly, we will make the base for flow control. We will make the base for congestion control, error control. Then you are get to know. We are just solving the first piece of a complete puzzle, which is connection establishment, and why we are making connection establish, why we are doing connection, right? If we know all these things, we are good to go. And believe me, this way we are going to create the complete TCP header. Right? We know till now this only these things, that is perfectly fine. But by the time of 8-9 hours, means in next session or next to next session, whenever we are done, we are going to definitely make sure that we are going to create our own TCP header, which is going to be exactly same, right? Whatever you have read from anywhere. So now one more thing which is very easy to understand, but which creates a lot of problem. So if you do not see the proper communication, right, that there are two streams. If I say there are two data streams, one from Anjali to Rahul, right? If I write is here, one stream is from Anjali to Rahul. Anjali is saying, Rahul, you there? Right? And Rahul is saying, yes, I am here, acknowledging her. Similarly, Rahul is saying, Anjali, you there? And Anjali is acknowledging it. Yes, I am here. Right? But you can say this is the difference which we have in normal phone conversation and computers or the TCP conversation. Because here if Anjali asks Rahul, you there? And if we say yes, then obviously Rahul knows that Anjali is already there. Right? But why we are doing this kind of two-way communication or two streams communication in TCP? Let's try to understand that. So first thing first, there are there are two separate streams of data. One is that if Anjali is sending one information, suppose this is the sequence number 1, length is 100, right? This is the data Anjali is sending to Rahul. Rahul is saying back that acknowledgement 101. It means that data till 100 is received. He is expecting 101, right? Similarly, Rahul can send the information towards Rahul, and that is a totally different stream because we are talking computers here. One stream is from Anjali to Rahul, and Rahul is acknowledging it. This is the one stream, and I am marking it with the name 1, number 1. This is one stream. This is the second stream where Rahul is sending information that Anjali, my sequence number is 500. That is totally different, right? So we need to make connection this side for this, and basically Rahul also need to make sure that he is saying that Anjali, I am going to send a packet from sequence number 501. So there is a connection from this side also, right? Two different stream. Just try to understand. One from client to server, server is acknowledging it. One from server to client, client is acknowledging it. It is as simple as that. If you understand whatever we have discussed till now, we are really, there shouldn't be any problem in understanding now the TCP handshake. and let's try to discuss that. Now we are into the mode where we can understand TCP handshake, and where I specifically mention that whether it is a four-way or three-way. You all know it's a three-way. Let's try to understand what exactly it is. But before doing that, before going into that, what I want to do is I want to open this bridge, this meeting again for some of the questions, right? Let's talk about some of the questions for 5-10 minutes, and then we will come back again with the handshake. And believe me, if you have attended this session till now, it is going to be important to see everything in WireShark, the packet pies. Okay. So if I can see that there is a question from Gopal. Gopal, can you ask your question, please? Gopal, I am not able to hear you. Extremely sorry. Okay. Sashank, can you ask question? Sashank, yeah, go ahead, please. Mhm. Yes, yes, Sashank. So the question is on MTU and MSS, but believe me, this is not the right time to talk about it. Just wait for another session. We are going really deep into that MSS and MTU thing. Do not worry about it. Again, I'm saying that we will go right into that. Basically, TCP layer, there is a communication between TCP and IP, right? After that, they come to know about what is the maximum segment side or MTU value on the data link which is connected to this laptop or computer, right? But believe me, do not worry about it. There is the one of the main concept, but right now we are not going to discuss that because it is going to take time. But yes, I will be covering that for sure. We will share the recording, because if I explain that again, if you go through that recording, it will be there. But what I wanted to share you is, suppose there are two people. So the question is, guys, how we can make a connection, virtual connection over the connectionless service, which I explained. So we have a client, we have a server here, right? Guys, please on mute, who is not on mute. So we have a client, we have a server, right? So, and we have IP layer. We have basically IP network. How we can make sure that the connection is there? And that is what I'm saying. The client is saying that here is my initial sequence number. I am going to start with this initial sequence number, right? And are you there? This is the connection, guys, because when you make a phone call, you make a connection. This is the connection which is happening. Now you can say that IP is connectionless. This packet can be lost, whatever you are sending. I will start a timer of 30 seconds. If I do not receive anything from the server side, I will send it again. So there must be some time this IP is going to deliver this message and I am going to get this message back, right? But the whole sole point is IP cannot do that. If something is missing, IP cannot turn the timer on, because this is not the responsibility of IP. IP's responsibility: take packets, send away, take packets, send away, and that is it. But if we implement TCP on top of IP, then we can make this connection over this connectionless service. If you do not get it, I am pretty sure that just go through the recording, which we are going to provide only to the registered folks, by the way, guys. So you will get it. No worries. So anybody else like? Yeah, Gopal, I can hear you now. So the question is basically when Rahul, when Anjali initiates a connection to Rahul, right? It is going to initiate its ephemeral port, maybe 1, 2, 3, 4, 5, and Rahul is listening. Rahul servers is listening on port 80. But now you are asking that what happened if this guy is opening a port, right? If it is opening a same connection to this guy, for example, if a packet come over this connection 1, 2, 3, 5 to 80, and if it is replying over that, then basically obviously it knows from the TCP header that the initiator is 1, 2, 3, 4, 5. It can reply that. But now if your question is that what happened if this guy make a connection with somebody else, right? Then it is going to open its own port, maybe 3, 4, 5, 6, whatever the ephemeral port, and then it's going to connect with this guy. So ephemeral port is not the one only that you can open, only 1, 2, 3, 4. There are a huge number which TCP can use to open a port. Yeah, the gain 80. So suppose that person is here. Suppose this is Rahul, this is Anjali, and this is Mr. Gopal, say, right? If he is initiating a TCP connection, what it is going to do? It is going to source IP address, Mr. Gopal IP address, IP port, Mr. Gopal's IP port, which is going to be different than this 34567, say, right? And so a destination port, it is going to be 80, right? I'm not saying that a person cannot listen to multiple requests on this port. I am saying that no two application can run on the similar port, but on a similar port, a individual can receive multiple requests because those requests are going to be different. From Anjali's IP address and Anjali's source port is going to be totally different than the Gopal port. So this connection is going to be different than this connection. You are getting my point? I think you got it. Perfect, Mr. Gopal. And thanks to asking a good question. And Sashank, as you praised me that you are a good fan, thank you so much for that. Means I really need those appreciation because I am creating a lot of videos for you, and these appreciations are actually kind of getting me go over and again for such kind of content. Thank you so much again, Sashank. Yes, do we have any question, Ankit? You can, yeah, Pankaj, yeah, please go ahead. It's a fantastic question, but I afraid that how can I going to take the transport layer out from the TCP stack, TCP IP stack? I am really not sure about it. Those are just the analogies, but I this is what how I learned when I started TCP, because I was thinking and thinking a lot that if TCP is not there, because if you remove TCP, then those are going. So guys, the question was, because this question is not audible in the recording. So the question was that can we do this experiment of removing the transport layer and check whether the messages are going? So this is the sometime the problem, because this is my way of teaching, because this is how I visualize thing, that if transport layer is not there, this could be the problem. And believe me, most of the time it is correct, the thinking which I think so. uh, but I really afraid that you cannot just take out the transport layer unless you are a programmer. If you are a programmer, then maybe you can switch that off, the transport layer, and can see. But I really do not. I can't help you in that, because I have a pretty limited knowledge in network programming. Yeah. So having said that, Ankit, yeah, you were asking something. Again, Ankit, it's a good question actually. Perfect question. So if I explain you, then there are only few things which can happen. A client can be a server can be a client. It's not a problem. Only few scenarios can come up. Maybe suppose we have two routers, right? So the question, guys, here is, I'm extremely sorry I haven't mentioned. The question here is, if we run BGP, right, over between two routers, then BGP runs over TCP. So first there is a TCP connection, then basically BGP makes its whatever the route it exchange, right? So how exactly this happens? Who is the initiator? Who is the basically server in this case? Who is the client? Who is the server? So there are only few cases which can arrive. For example, if you have configured BGP here first, right? And you basically, so once you do that, the important part is whenever you enable BGP, this guy start listening on 179 port. This guy is a server also, and this guy start initiating a connection towards 179 of R2. Similarly, this guy also done that. 179 it gets start listening to. By the way, guys, if I'm saying that if I have a host who is running a web server, it means that this server is whenever we say a website is up and running, it means that this server is listening over port 80 from the connection request from many guys. Similarly here, if I'm saying that BGP, you have enabled BGP on R1, it start listening on 179 and start sending message to 179 to R2 by opening an ephemeral port also, right? Similarly from here, 179 port, it is listening and it is initiating a connection with an ephemeral port. Only two or three possible cases can be happen. R1 connection request goes first to R2, then basically the connection will go through. R1 is going to be the client, R2 is going to be server. The second thing which happens, R2 is initiating the connection, and that connection request gets reached before it is reached here, right? So this way, basically, R2 is going to be client, R1 is going to be the client. But there is one important scenario. What is going to happen when both of them starts at the first place, right? At the same time. And then there is another way which we call a TCP four-way handshake, which we are going to discuss. Do not worry about it. That what exactly happens when client and server initiate the connection at the same time. What happens? But do not worry. The question is pretty good, but anybody can be client or server. The socket means, actually the socket is the question is, what is the meaning of socket? So it is really great to hear such questions. It means that you guys are taking interest. So the question is what the socket is, because you guys have heard a lot of information from the for lot about this term, the socket. For example, suppose I have this server, right? Let's not let's go here. Suppose I have a server here on which I am running my website, which is listening at port number 80. The IP address is 1.1.1.1. Suppose, right? And I have many laptops over internet who wants to connect to me. This is the internet. I am connecting the server here, right? Suppose the IP address of this laptop is 2.2.2.2. This laptop is 3.3.3.3, and this one is 4.4.4. All are public IP addresses. All are available on internet, right? Now, this guy wants. Suppose we have a server. We have the question was actually that what is the term socket means, because this is this you hear from a lot of times. So what is going to happen? This guy is initiating a connection, the TCP connection from here to here, right? We need to identify this flow, and to identify this flow, we need some information, right? So to initiate this flow, this guy has opened a ephemeral port, suppose 1, 2, 3, 4, 5, right? So how you are going to define this TCP stream, this TCP flow? You can define it via that this is initiated from 2.2.2.2 towards a port which is 1, 2, 3, 4, 5, right? Again, we are having, it is going to make a connection to 1.1.1.1 at port 80. This information, actually this complete information, is identifying a particular TCP flow which is unique, and this is called as TCP socket. Similarly, suppose there is another connection from this guy to this guy, which I am showing you in yellow color, right? So what is going to happen here? If I write this socket value again, 3.3.3.3, it is going to open up a ephemeral port, maybe 5, 6, 7, 8, or anything, right? Or maybe the same. It could be the same, 5, 6, 7, 8, but the destination is going to be 1.1.1.1 colon 80. You can see this is the one flow, this is the another flow, but anybody can see this information to know that with this socket information, I am representing yellow color or yellow flow, and with this socket information, I am representing blue color. I think you get the point. I think you get the socket, right, guys? So here you go. Now let's talk about TCP three-way handshake. And I hope till now you have enjoyed this session, and let's see the remaining concepts. Okay. So participants, here you go. Okay. So we have TCP handshake, how basically it happens. Let's talk about this. So I know you all understand why we need a connection. We have a connection, a less service, and that is why we want to make sure that there is some other person. We want to make sure that we send some information to him, that I want to start from this this thing. So This is again Anjali, this is Rahul, right? So Anjali wants to talk to Rahul. Its laptop is going to start a connection towards Rahul. Okay, and first thing first, it is sending one packet through which it wants to check whether you are there, Rahul, you are there, and the second information in this packet is going to be whether that I am going to start from this sequence number, right? So that is why we are calling this packet as the synchronization packet. Why synchronization? Because it is synchronizing the sequence number of Anjali and Rahul. And that is why I have marked this flag. The SYN flag value is equal to 1, which means that this is the SYN packet. And basically, what is the sequence number of this packet is 0. Although basically no communication is going to start from 0 number, but for simplifying things, and WireShark also does that on its own to simplify things, we are going to start the communication from 0, right? Length, because I am not sending any data. First of all, I want to make sure that Rahul is there, right? And then I will send the data. So length is 0, sequence is 0, SYN is equal to 1, which is the flag. So we are sending these three information here, right? Although acknowledgement also goes, acknowledgement number, which is again 0, but that is not making any sense to discuss now. That is why let's leave it for now. So sequence is 0, length is 0. This is going to be the first packet which is going to be as a part of this connection. Through this packet, Anjali is saying, Rahul, you there? And this is my synchronous packet, and I'm going to start marking my packet from 0, right? Rahul says, okay, Anjali, I acknowledge you. He's saying acknowledge 1. So he's saying that I acknowledge that this SYN packet has been received by me, and now I am expecting a packet from sequence number 1, right? Although you can now argue with me that if TCP has some bytes of information, right? 1 byte, 2 byte, 3 byte, 4 byte, and I'm starting marking the packet from 0 number. This first byte is my 0, then 1, 2. I'm not sending anything. There is no data. How can you mark with how can you mark this with sequence 0? This is the sequence in itself. You can argue with me, but this is how TCP is implemented, right? Uh, and so they call that there is a ghost bit. There is not any bit, but Rahul is saying that sorry, no, not any byte, but Rahul is saying that your sequence number 0 is received, and I'm acknowledging it. Then I'm saying acknowledgement number 1. Do not get confused, because there is no way other way than that to how to synchronize the packet. Anjali is saying my sequence number is 0. Rahul understand that your sequence number is 0, but the packet length is also 0, right? If the packet length is 0, but Rahul has to say that your packet has been reached. So that is why there is a first exception that Rahul is saying that, okay, I received sequence 0, right? But during any other communication, any other packet exchange, it is not going to be there. The ghost byte is only for the SYN packet and nowhere else, right? So sequence 0, length 0, Rahul is going to say acknowledgement number 1. I am going to, if you want to send data, send it with sequence number 1. Similarly, Rahul is sending its own sequence packet, because as you remember that we are having a 2 streams. One is from Anjali to Rahul, the other is from Rahul to Anjali. Rahul is saying my sequence number is 0, my length is 0. I am also sending you a SYN packet. Anjali is saying acknowledge, right? So there are, guys, 4 packets. One is this SYN, other is acknowledgement from Rahul, third one is SYN again from Rahul, and fourth one is acknowledgement for Anjali. So why we are calling it a 3-way? It is a 4-way handshake, and the complete process, whatever we are doing to make that connection, is known as TCP handshake. But you must be thinking Vishnu is teaching us wrong. Why there are 4 packets? There are these many packets. It should be these many packets, but some intelligent guy comes and he said, why cannot we have, instead of these 2 packets, why can't we make this 1 packet? And we can pretty easily. Along with this acknowledgement number, what we can do is the third packet we can send in this acknowledgement only. So I can say that this is also a SYN packet, SYN equal to 1. also an acknowledgement packet, and I will be saying sequence is 0, right? So in the same packet, in the same segment, I am acknowledging the SYN packet of Anjali, and I am sending my own SYN packet. So you can see there are two flags. SYN flag is set, acknowledgement flag is set, and the sequence is 0. So we call this as SYN plus ACK message. The first message was only SYN and the third message was ACK. So the complete exchange, instead of having 4, this intelligent guy is combined second and third, and that is why we are having three-way handshake. First SYN, second SYN plus ACK, third is ACK. It is as simple as that. I think I wanted to make sure that you all understand this, right? So instead of showing you 4, I am showing you here 3, like this. Okay. First packet is SYN packet, which is from here to here, from Anjali to Rahul. Second is SYN plus ACK, from here to here. This is the single packet which is doing two tasks. One is it is acknowledging Anjali's SYN that yes, I am here, I am acknowledging you. And then basically it is saying that when I send data, I will be starting from sequence 0. Although these two numbers can be different guys in actual transfer, but I am just simplifying the thing. And I will showcase you everything on the WireShark so you can understand that. Then basically we have sequence is equal to 1, acknowledgement is equal to 1. It is as simple as that. I think now you all understand three-way handshake, which is very, very important. And we just learned. So we have a complete TCP problem. We divided into 4 parts, right? We just learned the TCP handshake. We are going to start the flow control in a while. But before starting that, we are going to see everything on WireShark, right? So without wasting any time, what we are going to see is we are seeing everything on WireShark. So I have taken an example for this, that I have this laptop here whose IP address is 192.168.1.104, and the local port which I have initiated for this TCP connection, the same thing, SYN. In the SYN packet, basically you are mentioning the port also, right? SYNAC and then ACK, right? This is the TCP connection which is going on the socket. And what is the socket information? IP address is 192.168.1.104. The destination IP address is 216.18.166.136. This is the server present somewhere on internet. As simple as that. Local port is my ephemeral port, which is 49859, and the local port of the server is 80. So there is a connection going on between this guy and this guy. What we are going to do, we have captured a three-way handshake process on this yellow wire, and I am going to showcase you that. Right? Let's see that. So I'm opening the WireShark, and I hope you all see my WireShark here, right? So first of all, to let you know, to make sure that you understand things well, what we are doing here is there are 3 packets which you can see right here. Okay, let me open the marker here also. Just give me a minute time, guys. Okay, here you go here. Okay, you go here. Okay, so we have marker now. So you can see three packets here: packet number 1, packet number 2, packet number 3. Right? First packet is SYN packet, another packet is SYN plus ACK, and the last packet is ACK. This is my source and this is my destination. You can say that there are so many things like window, length, MSS. Believe me, when you are done with this course, you can understand everything, right? But for now, let's try to understand there are 3 packets: SYN, SYNAC, and ACK, right? Those are similar. Those are the same thing which I was talking about, right? We have this client. The client IP address is 192.168.1.104. The server IP address is 216.18.166.136, right? So there is a connection. We have ports also, and we have a TCP connection. There is going to be a three-way handshake. First packet is SYN. Let's see what is there inside this SYN packet. Okay, so I am opening the SYN packet here. So first packet is this one. Now if you can see on this window, right? This window. Okay, sorry for this. Extremely sorry. Yeah, if you see on this packet itself here, as I mentioned that we collect data from application, then we put what? We put TCP header, then we put IP header, and then we put data link header, right? And then we encapsulate everything in a frame and send it out, right? So exactly whatever you are seeing here, the data portion, the data link layer header is this one, guys, where we put source MAC and destination MAC, right? We have IP header, which you can see here, which is having important fields like source IP address, destination IP address. You can, so by the way, I'm using this WireShark file from wireshark.org. You can download it, open in WireShark, see every piece of it, because it is really important if you understand from the packet itself. We are right now seeing the packet, okay? And then basically there is a TCP header, which is you can see right here. Okay, and now our point of consideration is not IP, not data. We are going to see what exactly this TCP contains. This is the first message, which is the SYN. So first thing first, we are going to check whether this is a SYN flag or not. SYN flag is enabled or not, right? So if I open this, the first thing first, I would like to see whether the flag is there or not. And you can see the flags right here in the TCP header, right? You are seeing that there are several flags like urgent, acknowledgement, push, reset. We haven't read about them. We only know about acknowledgement and SYN till now, right? So you can see SYN is set here, which value is 1. So 1 flag means this flag is up, which is proving this packet is the SYN packet, right? Let me clean the board and let's do let's see some more fields here. So source port, very simple, 49589, right? The client port, the ephemeral port is 49859, right? The destination port from here is port 80, right? Then sequence number, whatever the TCP frame you have created, right? It is going to have the sequence number, which is going to be 0 in this case. And by the way, this is relative sequence number. As I mentioned, the sequence number field is 2 to the power 32 bit long, right? Then the number values can be pretty large. So this, the actual value in which is used in this communication is this one. But Wireshark is so generous that it has started everything from 0 so that you can understand the communication, right? But if you want this value to be there, you can set the configuration in Wireshark itself. Next sequence number is going to be 1 for sure, because 0 is the first sequence number, SYN packet, and Anjali is going to say that, okay, sorry, Rahul is going to say that I am expecting ACK1. We are going to see this also, right? The similarly, we can see acknowledgement number, which is not having, and that is what basically window and everything we are going to learn at later point of time. So this is what we have here, right? And now let's talk about, and yeah, one more field, the TCP length, which we were forgetting. I was forgetting. The TCP length is again 0 because in SYN packet there is no data. There is no data at all. So FIN flag, we have seen it is set. Length is 0. And sorry, not FIN. The SYN flag is set. Length is 0. We have seen everything, whatever we wanted to learn here, right? If I want to showcase you this thing here also, you can do the WireShark setting. I can tell you that how we can do that. So transmission control protocol, actual header you can see in the diagram form, transmission control protocol, right? And we know flag 002 means it is a SYN flag. Acknowledgement number 0, sequence number 0, source port this one, destination port this one, destination address this one, right? So you can see every all the things, you can see IP packet, you can see Ethernet, everything you can see here, right? So SYN packet wise we are good. Let's try to understand more in terms of SYN-ACK. Let's clean the board, and now I am into the second packet, which is my SYN plus ACK message, right? So let's see the flags first here, whether it is going to be SYN plus ACK. And yes, exactly, the acknowledgement number is set here. Here you go, the acknowledgement is set here. Just wait a minute, this is not letting me work. Okay, it is set here. Then SYN is also set here. It means that this is the second packet which is coming from the server towards the client. SYN plus ACK. It is as simple as that, right? So flag wise we are good. Now let's try to see what we have in terms of other parameters. So we have source port 80, of course. Now it is from the server towards the client. Server is listening at 80 and it is responding now. So the source port is going to be 80 and the destination port is going to be the ephemeral port, which is exactly the same. And that was the socket which we have done, right? This port was open at the client, which is 49859. It is as simple as that, right? Now the message is from server towards the client, and that is why we are talking about SYN plus ACK. We have here the length is 0. Again, there is no data. The sequence number is 0 because this is a SYN packet from the server towards the client, and it is saying that I am SYN. I am acknowledging the initial SYN sent by you. It is as simple as that. The last packet is going to be SYN plus ACK. Here you go. Here you go, right? So let's see once again. First of all, yes, we have the acknowledgement flag set here, right here in the TCP header. And if we go up and check the remaining fields, what exactly the fields are, we have here sequence number, which is 1, of course, because now previously I was sending sequence number 0 as a SYN packet. I received sequence 0 as a SYN plus ACK, and now because acknowledgement was for 1, the server is receiving the first sequence number first. That is why I'm sending sequence number 1 here. It is as simple as that, right? Sequence number 1, acknowledgement 1, and I think you get the concept now, right? Similarly, you can see all these values here also. Believe me guys, if you want to understand networking better, make WireShark a good friend of yours. I have seen a lot of guys have explained TCP over the WireShark, but the problem is if you do not understand the basics of TCP, how you are going to learn that what is going on, right? And believe me, if you have spent hundreds of hours in learning BGP, OSPF, and so many things, I am just asking you for 15 to 16 hours of yours. Although I'll try to finish this course in 11 to 12 hours, right? But if you give me that amount of time, I'll make sure that I am going to simplify TCP for you. You are going to understand it really well. Having said that, let's move towards our board once again. Wherever possible, I will be showing you all these, whatever we are going to learn, like selective acknowledgement, options, flow control, whatever we are going to learn, and whatever we can show on wire, we can show. I will be happy to share with you. Okay, let's move again towards our board here. Let's delete this thing, and now we can see we are having a pretty good thing here that we have seen everything in WireShark. Okay, having said that, let's go and check what we have in another board, right? Flow control. What I am suggesting you guys, let's open this bridge, let's open this meeting for the questions now, right? And why I'm saying this, because we still have 20 minutes, right? If I can open everything for question, because if we want to learn a new concept altogether, it is not going to work. I have to let that in middle, right? So flow control, we are going to learn in next session, right? But yes, now what I'm going to do is I am opening this meeting, the conversation to everybody. You can ask your questions, right? Haha. Yeah. Mhm. One thing, first thing first, before going into the data thing, right? I have, see, sorry to interrupt you because I know what your question is. Right now, there are two parties, client and server, if you can see here, right? We have just done only one thing. We have just made the connection to this guy. This guy just made the connection to this guy. That is it. Entire data thing is coming to you. We are going to send data from here to here. What should be the sequence number acknowledgement? Everything. I will be showcasing you everything over WireShark, right? And then we are going to talk about finishing this connection also. So we are not done. In the first class, we have just understood this. Believe me, a lot of information is coming. We are going to understand the flow control, and inside that, if you have data, then you are going to flow control it, otherwise not. We are going to learn about this. No. So basically, the question is, if I understood it properly, what is going to happen if Anjali is going to open two TCP stream because one TCP stream got missed? Is this the question? Second sequence, no, second sequence number is nothing here, right? We are, see, you are confusing two things. You are confusing, we are on the handshake portion and you are talking about data. The second thing is only going to come when this connection is established, right? If this connection is not established, if this message is lost, if this message is lost, then the connection is not there. Data transmission cannot start. Oh, slide number. That's basically, I was just showcasing you the data part here. Basically, I was just explaining sequence number and that. But believe me, just give me a time of 1 or 2 hours more into this session. Then you can, because I was explaining only sequence number and acknowledgement, I haven't included the data part yet, right? So just try to understand only what sequence number and acknowledgement are from this slide. But whatever you are asking, there is a logical answer for that, and we will be covering that in the next session. Do not worry. Okay. So I think there are question from Abhay Nagar also. Abhay, yes, please. Yeah, from server to client in the initial handshake. Yeah, so you are saying this thing that I have received the initial packet for the TCP transmission. The initial packet was with sequence 0, right? And with this acknowledgement 1, this Rahul is saying that I have received the sequence 0. Although there is no such data, anything, but this is the how TCP works. This is how they have implemented it. That through acknowledgement 1, they are saying that sequence 0 is received, right? And this is the way of informing Anjali that if Anjali is receiving acknowledgement 1, then Anjali is pretty sure that my SYN packet is received at Rahul end. It means that why I was making connection, I want to make sure Rahul is there, right? So I have sent sequence 0. Yeah, go ahead. Yeah. That is what I'm saying. Just wait for data, guys. You are going ahead, right? Just try to consume all these things, right? This is a 2.5 hour talk. If believe me, if you are good with this basics, data transmission is just going to be piece of cake for you, right? We will be covering that. In fact, we will start that. For example, as I mentioned, we have just covered connection establishment. We are going now. The next phase is we are going to send data, receive data, and how are going to be those acknowledgement number, sequence number. I will be showcasing you right there in the WireShark also. Then we are going to finish this communication, right? There are 3 steps. We are at the first. Just try to understand everything, and then basically this is going to be piece of cake for you for sure. And that is not going to take even 20 minutes for me to explain you, but we do not have time now. Sorry for that. Yeah, yeah, go ahead please. Definitely, we are going to cover it. There's a complete discussion is going to be over on these TCP timers value. Absolutely, right? So the question was basically if TCP, if Anjali is sending this SYN message, and if the SYN message is uh, uh, lost somewhere in the network, how it is going to happen, right? So the Anjali is going to set a timer. It will send it again. What are the timer values and all? So we are going to cover it. We are do not worry. There is still almost 8 hours, 8 to 10 hours in this course, right? We are going to discuss each and everything. Anybody else? Sashank Bhargava? Yeah, please go. Yes, yes, yes. Yes, it is exactly saying. Just consider the analogy of that restaurant. So the question is, but that basically I'm sending the sequence number. What is the significance of SYN? SYN is just a way to let Rahul knows that the segment you are getting is a perfect segment, although its length is 0. But this is the SYN fragment, right? So this way Rahul sees that, okay, this is the SYN fragment. So whatever the sequence number is, it is a sequence number with which Anjali is going to start, right? With the next one. So it is just signifying. This is the flag. This is the flag, right? Which is just signifying that this is the SYN, right? If Rahul receives it, it means that there is a understanding in this protocol that if I receive a packet with the SYN flag set, it is the synchronous bit. I need to make sure that that Anjali wants to send an information that she is going to start with delivering data from sequence number 1. This is the whole sole purpose only. Okay. Yeah. Anybody else? No, no, no. It is only that. So the question is, what this length is equal to? What is the length field signify? This is the actual number of bytes which we are receiving from the application. This has nothing to do with the header length. Okay. For the header length, we have another parameter, but this length is equal to 0 is signifying that we haven't received anything from the application, or we have, but this segment doesn't have any data in it. If it says the length is equal to say 1500, then basically it is saying that the data part, basically this packet entirely, the data part, so the payload part contains 1500 bytes of data, which TCP is going to mark with 0, 1, 2, 3, 4, 5, 1499 if it is starting from 0. Okay. No, no, no. It is going to be the same circuit. Socket is not changing. See, source IP address, destination IP address, source port, destination IP address is not changing in either direction, you can say, right? The socket is basically is identified by 4 parameters: source IP, destination IP, source port, destination port. This is not changing, right? Although you can say source IP is interchange when this guy, but this connection, this complete connection can be represented by this for information. Although this can go here, this can go here, right? But socket is going to be same. Yes, yes. Yeah. Yeah. Go ahead, Prakash. Anybody else? Ankit Goswami ji. No, if I say payload, if it is the length, whatever I'm receiving from upper layers, right? So if I receive say 1200 bytes of data, right? This is going to be my payload. And then I put TCP header. So suppose I put 20 bits of 20 bytes of, and then it is going to be 1220. But for IP packet, right? This TCP plus 1200 byte of data is going to be payload. And this is header. Similarly, for data link layer, this thing is going to be payload and this is going to be the header. I think you get it. Yeah. Yeah. So basically in the TCP, the question is that we are sending any data in the first packet, the SYN packet, and we are not sending because the length is 0. there is only the handshake mechanism. We are just saying here that here is my SYN packet with length 0. There is no data, right, in it, and can you acknowledge it? That is it. Although I understand your concern that if there is length 0, then what exactly you are acknowledging. So that is why there the ghost byte comes into picture, right? So presume that there is 1 byte of information which we are marking with sequence 0.